Looks like business as usual on this batch of lamps. All okay. I mean to say, we seldom get it wrong on final QC. Well, what I really mean is...
What Mrs. Windsor means is that during the years she's worked in this quality control section, only a small percentage of the thousands of lamps that she has checked have failed to reach the required standard. This is partly due to the many previous checks that the lamps have undergone, both during and after manufacture. But Mary Windsor knows this. She's worked in practically every QC department during her 33 years with Thorn Lighting. Right now she's checking a conventional projector lamp, type A1207, which first began to take shape when its filament mounts were spot welded together in an assembly. After a preliminary light-up in a controlled atmosphere of hydrogen, which stabilizes the crystalline structure of the tungsten wire, every filament is checked for position on projection apparatus. The accuracy of filament location is checked again on every lamp immediately after the capping and focusing stages of manufacture. The checks are repeated later as part of a statistical sampling procedure by a completely independent quality control department. Then, after 1 week in storage, the lamps are rechecked for any signs of minute hairline cracks in the glass.
There's a coincidence. A batch of tungsten halogen lamps of exactly the same type as the conventional ones that I've just been checking. Well, not exactly the same, because the tungsten halogen's a lot smaller. What I mean is, you can use them both in the same projector.
What Mary really means is simply that Thorn's backroom boys have developed a whole range of tungsten halogen lamps for use in conventional lamp projectors. Now, compare the light output of a 300-watt conventional lamp with that of a 300-watt tungsten halogen lamp. The extra 10% given by the latter will remain constant throughout the lifespan of at least double that of the former. This, obviously, is an illustration of two photographic lamps. What is not so obvious is that they are both rated at 5,000 watts. That they both have an output of 135,000 lumens, that they are completely interchangeable with each other, and that one of them will enjoy at least double the lifespan of the other, with no loss in performance. Lamps that operate on the tungsten halogen principle represent nearly 1/5 of the 343 different types made in 17 differing voltages by Thorn Lighting Limited for a wide variety of photographic uses. This This means something like 1,600 different kinds of projector models and more than 250 lighting units, as used by theatre electricians, amateur photographers, and professional cameramen. Oh yes, lighting cameramen very soon came to appreciate the superior qualities of tungsten halogen lamps. This is no ordinary household gas flame. It's a rather special mixture. But then the material being worked is not ordinary glass, which softens at about 500 degrees centigrade, but fused silica or quartz, with a melting point for around 1800 degrees centigrade. Users of photographic lamps make exacting demands on the lamp manufacturer. Correct color temperature, maintenance of light output during the lamp's lifespan, physical sturdiness, and in this age of increasing miniaturization, smaller lighting units. The advent of the tungsten halogen principle, coupled with the use of quartz envelopes, launched a major breakthrough in lamp design, a great stride towards the fulfillment of those exacting demands. The operating temperature of the filament in a tungsten halogen lamp is well in excess of 1250 degrees centigrade. And because a quartz bulb is quite capable of withstanding the temperatures of this order, the size of the bulb, by comparison with a conventional lamp, can be drastically reduced. Indeed, the volume of such lamps may be as little as 1% of their conventional equivalents. Not only do bulbs of such relatively small dimensions allow for more compactness of lighting units, it also, because of their far greater physical strength, permits them to be filled with halogen at pressures of up to 5 atmospheres, sometimes even higher. This, in turn, helps to retard evaporation of tungsten from the filament, and so increase its lifespan. Furthermore, because the filaments of tungsten halogen lamps can be operated at somewhat higher temperatures, more of the energy is converted into light, as opposed to wasteful heat, resulting in more lumens per watt consumed.
Right little gems, these new studio lamps. And do you know, this double filament's actually rated at 5,000 watts. I mean, to me, a 5,000 watt lamp is a goldfish bowl. Mind you, we don't see a lot of them about nowadays. Well, not compared with the output of tungsten halogen projector lamps, I mean.
What Mary Windsor means is that in the various Thorn factories, several automatic machines produce a daily output of tungsten halogen projector lamps that runs into thousands, not to mention a vast quantity of comparatively low wattage photographic lamps. Quality control, always an intrinsic part of production.